Hello, welcome back. In this segment, I will talk about one of the important problems in computer science, P not equal to NP. P stands for set of all problems that can be solved in polynomial time. NP means set of all problems that can be easy to verify whether the answer is correct or not, but we don't know how to solve them. The long-standing question is, are these two set of problems equal? Meaning, if you know how to check whether the answer is correct, can you somehow magically use that technique to even find the answer at the very first place? That is the open problem. It's $1 million problem, literally $1 million if you solve that. And there is an interesting connection between P equal to NP or P not equal to NP with one-way functions, for example, that are used in cryptography. Okay, if we can prove that one-way functions exist, then we can conclude P is not equal to NP. Okay. One-way functions we talked about more formally, meaning functions that are easy to compute in one direction, difficult to reverse the value in polynomial time. Okay, that is the kind of functions we call one-way functions. All right, so we don't know whether one-way functions exist. If we can prove they exist, then P is not equal to NP. So now how am I going to approach this? The way I'm going to prove is I'm going to negate both sides. I will assume P is equal to NP, and I will show that one-way functions don't exist. Logically speaking, they both are same, right? If I have a logical statement saying A implies B, that's same as saying not B implies not A. Okay, that's basically what the reverse direction is. Okay, so let's define a set L made of pairs y comma x prime. Okay, let me explain what is y. Y is the value obtained after you apply the function f on a prefix x prime. Okay, that means there must be a suffix x double prime, and you call your one-way function, right? F of x prime followed by x double prime. This means string concatenation will give you y. Okay, so what I'm going to do now is I'm going to assume P is equal to NP, right? And I'm going to show that there are no one-way functions. Okay, that's what I'm going to show. That means given y, it is easy to find the input in polynomial time. That's what I'm going to show. Okay, so clearly this language L is in NP. Okay, why do I say that? The language L is in NP because a machine that can make multiple guesses at a given moment, which doesn't exist, it's just a theoretical concept, given y, right? Given y and x prime, it can magically search through all possible x double primes in polynomial time and can tell you whether f of x prime followed by x double prime is y. Okay, if that is the case, then you know for sure that machine is a non-deterministic machine that can recognize this language L. Okay, so clearly L belongs to NP because you can also reason it this way. If I say L belongs to NP, all I have to do is I have to give you a certificate. This certificate means this x double prime. You can just take your y and x prime and plug in the evidence x double prime to your function f and check whether f is f satisfies this constraint x prime followed by x double prime is y. Okay, so it is easy to verify the answer. That means it's a NP problem. Okay, so L belongs to NP. Okay, but now I will show you that if we assume P is equal to NP, right? Given y, I can invert it and find out the input that went inside, meaning what is the value of x given y. Okay, that's not an easy problem, but if we assume P is equal to NP, that becomes an easy problem. Let me show you how. Since we assumed P is equal to NP, right, what we can do, we can start our x prime to be, let's assume x prime is just 0. Okay, and I can ask the machine now, does y comma x prime belong to L? Okay, what does it mean by belonging to L? It means the input to the function f starts with the 0 as the value. Okay, you can imagine like this, f of 0 followed by something, we don't know what that is equal to y. Currently, we don't know how to direct this in polynomial time, but if you assume P is equal to NP, then it implies that there is a polynomial time algorithm that will tell you whether pre-image of y starts with 0. Okay, that means you learned whether it starts with 0 or 1 in polynomial time without trying all possible x double primes. Okay, so you learned the first bit of your input X, okay, the most significant bit. Now what you can do is you can construct a new string as follows. You take your old 0, right, and you add a 0 to it, okay, and now you ask, is this updated? This means you're concatenating, okay. Now you ask your algorithm, is y x prime part of L? Okay, again, because we claimed that NP is same as P, there must be a polynomial time algorithm that will answer this question, okay, which means you also now learned the second most significant bit of X. Okay, let's just assume the answer turned out to be not in L. That means you know the second most significant bit is 1, right? Either it can be 0 or 1, so it has to be 1. So by doing this query bit by bit, you will be learning all the input bits of the function f. Okay, remember, given y, it's difficult to find x such that f of x equal to y. But if we assume that p is equal to np, right, that's the assumption I made, which means all I have to do is just use this machine, or this language rather, and ask the underlying machine. When I say machine, it means a Turing machine as a concept. Is this particular pair belonging to L or not? The Turing machine will tell in polynomial time yes or no, because we assumed P is equal to NP. Therefore, what we proved now is that if P is equal to NP, right, there cannot be any one-way function. That's a remarkable result. So many of the computer scientists are hoping that P is not equal to NP. But if P is equal to NP, we are in deep trouble, because then there are no one-way functions. When there are no one-way functions, essentially there are no digital certificates, and pretty much the entire cryptography breaks down if there are no one-way functions. Okay, so let us hope that P is not NP, at least from a cryptographic perspective. We would like to have one-way function. Otherwise, if P is equal to NP, we are in deep trouble. Okay. Okay, thank you very much. That's all.